Usually, like when we talk about a software bug, there's this expectation of a visible logical trail, right? You get a stack trace.
Right, or a test fails in CI.
Exactly. You open up your logging dashboard, the error points straight to, line 42, and you have that moment of clarity. You say, there it is. The system broke right here.
The mechanics of finding the break are solid. You can trust them.
Yeah, but modern software engineering has this new, honestly, terrifying trend. The bugs aren't in the code anymore. They're in our heads.
Yeah. It is a really profound shift in how we think about human capability, especially in the age of automation.
So today, we are opening up a stack of internal notes and documentation about a silent crisis that's hitting engineering teams, and a really fascinating, highly specific open source tool that's designed to cure it.
And we're looking at a phenomenon that researchers and engineering managers are basically calling AI skill atrophy.
Okay, let's unpack this, because the core of the issue sounds almost impossible at first glance. I mean, we're talking about senior developers.
Right, people with a decade or more of hands-on experience.
Yeah, people who have built incredibly complex systems who are just suddenly quietly forgetting how to code. Like they're struggling to spot glaring logic errors in their own pull requests.
Or they sit down for a technical interview and just, they cannot answer foundational questions about the exact technology stack they use every single day.
Which is crazy. And the immediate assumption, I think, if you see an engineer suddenly underperforming like that, is just burnout.
Well, which is a fair assumption, given the pace of the industry. But the documentation points to a much more insidious culprit here. It is not burnout.
Right.
It's not job hopping, and it's not context switching. The atrophy is a direct result of relying on AI pair programmers.
You mean tools like GitHub Copilot, Claude, ChatGPT, stuff like that?
Exactly. The very systems that are designed to give developers leverage and make them superhuman are, well, they're slowly draining their core competencies.
I mean, think about your own workflow yesterday, right? You need a complex email validation system. You write a comment, you hit tab, and boom.
The AI fills in 15 lines of dense, regular expressions.
Yeah. And the error handling logic around it. So you run the test suite, the tests pass, you commit the code, and you just move on to the next ticket. You feel incredibly productive.
Because you are. Shipping faster with AI is a real measurable phenomena. Nobody is denying that you get more tickets closed.
Totally. But the danger, and this is where it gets alarming, lies in the cognitive science behind what just happened in your brain.
Right. That is the core of the invisible disease here.
Yeah.
In cognitive psychology, there's this concept called the generation effect.
The generation effect.
Yeah. It basically dictates that information is better remembered if it is generated from your own mind, rather than simply read.
Oh, interesting.
So when you write code from scratch, you are actively building and strengthening those neural pathways. You're forced to understand the syntax, the architecture, all the edge cases.
But when you just passively read the AI's completion, you experience what psychologists call the illusion of competence.
Yes.
Because, you understand the code as you read it, so your brain tricks you into believing you possess the knowledge to generate it, but you don't.
You've entirely skipped the mental struggle required to encode that knowledge into your long-term memory.
Wow. So every single time the AI does the heavy lifting, you make this tiny, invisible withdrawal from your own knowledge bank.
And individually, each of those withdrawals feels completely harmless. I mean, you save yourself 20 minutes of wrestling with the documentation page, right?
Yeah, you ship the feature ahead of schedule, your daily velocity metrics look fantastic, your manager is thrilled.
But compound those invisible withdrawals over hundreds of coding sessions, over, say, 24 months.
You hit a catastrophic failure point. And the sources paint this incredibly vivid, brutal picture of what this looks like in the real world.
Yeah, it's pretty bleak.
You can describe broadly what a block of code does, but you cannot explain why the edge case on line 47 matters. You know an API call works because the AI wrote it and the test passed.
But you have zero idea what actually happens to your system state when that API call times out.
Exactly. And we see this constantly in code reviews now. You review a pull request authored by an AI. Everything looks logically sound to your passive reading brain, so you approve it.
And then 3 weeks later, a critical bug is reported in production.
Right. A race condition is corrupting user data. You look at the code you supposedly verified, and you cannot reproduce the issue. You lack the foundational depth to even trace the logic.
Your underlying mental model of the system has just been hollowed out. What's fascinating here is that this atrophy is completely invisible until the exact moment it isn't.
Yeah. And then one day, The AI gives you a subtly wrong answer, a hallucination that looks like 99% correct, perfectly formatted, confidently delivered.
And you just don't catch it.
Because you no longer have the depth to know it's wrong. You've entirely outsourced your critical thinking. So it's like mental muscle loss, right?
That's a great way to put it.
You're at the gym, you think you're lifting heavy weights and getting stronger, but the AI is secretly using this motorized pulley system to do the heavy lifting for you.
Right. So the question then becomes, how do we stop the muscle loss without throwing away the AI pulley?
Right. Because no developer wants to go back to typing boilerplate manually. The genie is not going back in the bottle.
No, definitely not.
Yeah.
Which brings us to the solution proposed in this documentation. It's a newly developed command line tool named Rocky.
Okay, so enter Rocky.
Yeah, and the developers behind Rocky aren't trying to replace AI or ban it from your workflow. They refer to Rocky as a discipline layer.
A discipline layer. Okay, what does that mean practically?
Well, it's built to run silently alongside your AI coding workflow and basically fight this skill atrophy directly at the source. It acts as a preventative immune system for your mental model.
Oh, I like that.
So every time you make a commit, especially one where AI wrote the code, Rocky reads the git diff.
Okay.
It parses the changes, figures out what underlying concepts you needed to understand to write that code correctly, and then it asks you about it.
Now, hold on. When I first read that in the notes, my immediate reaction was just massive skepticism.
Sure.
Because the absolute last thing a professional developer needs is a pop quiz. If this is just like digital flashcards interrupting my day to ask, what is a JSON web token? I'm uninstalling it in 5 minutes.
Oh, absolutely.
That is a terrible interview question, let alone a daily workflow interruption.
And the developers anticipated that exact pushback. If Rocky operated like generic flashcards, it would be worse than useless. It would be active friction.
Right. So what's the difference?
The vital difference is architectural context. Rocky does not test you on dictionary definitions. To use that specific example from our sources, Rocky won't ask you what a JWT is. Instead, it looks at the exact authentication service you just committed and says, you're using a 15-minute access token expiry here. What happens to users who are mid-session when that token expires? And how does your specific refresh token rotation handle it without logging them out?
Oh, wow. Okay, that shifts the paradigm entirely. That isn't a flashcard.
No, not at all.
That's the exact kind of probing question a rigorous senior staff engineer asks you during a really good code review.
Exactly. It's forcing you to prove that you actually understand the production systems you are building, rather than just doing keyword matching.
It demands genuine comprehension. But logically, how does a simple command line tool actually generate hyper-specific production-level questions about a unique, messy, proprietary code base?
Right, because a generic large language model doesn't know your database schema.
Or my specific business logic. So how does Rocky pull this off? The technical architecture under the hood revolves around a concept they call the personal knowledge graph, or PKG.
And this is really the engine of the entire system. Rocky builds this graph using a local SQLite database that lives permanently on your machine.
Okay.
It systematically tracks every technical concept you encounter in your specific code base. And each concept becomes a distinct node in this graph.
And here is the truly fascinating part. Every node in that SQLite database has a retrievability score attached to it. It ranges from 0 to 1.
Right?
And this score represents the mathematical probability that you will remember that specific concept if you were asked about it right now. And that score isn't static, is it?
No, it decays over time. And it uses an algorithm borrowed heavily from space repetition cognitive research, specifically something called the FSRS algorithm.
FSRS. What does that stand for again?
It stands for Free Space Repetition Scheduler. It's based on the forgetting curve, which was originally discovered by Hermann Ebbinghaus.
Right, forgetting curve.
Yeah, basically the human brain does not forget information linearly. It forgets exponentially. The moment you learn something, the memory trace begins to decay rapidly.
But if you review that information at the exact moment you are about to forget it, you flatten the decay curve.
Exactly. The neural pathway cements itself much stronger for the next cycle.
So if we connect this to the bigger picture, Rocky is mapping that exact decay curve onto your code. If a concept's retrievability score drops below 0.7, Rocky flags it as fading.
And if it drops further, it becomes a total gap in your knowledge graph.
Which is how the system prioritizes what to ask you. It isn't randomly quizzing you on your code base. It's performing targeted maintenance on the exact architectural knowledge you are statistically about to forget today.
It transforms an invisible process, that slow hollowing out of your mental model we talked about, into a visible, quantifiable metric that you can manage.
That's brilliant. But I want to break down how Rocky actually gathers this context, because the development team calls it the three-stage context pipeline. Let's walk through that.
Sure. So the first stage is the explore stage. When you initialize Rocky in a new project, you run a command called Rocky Explore.
And that just skims your files.
No, it goes way deeper. It reads your Git your Git history, the dependency manifests, and it even parses the ASTs, the abstract syntax trees, of your code base.
Wow. So Rocky understands the actual structural relationships of your code, like which functions call which services.
Exactly. It grounds the local AI model in your absolute reality rather than just relying on generic tutorial examples from its training data.
Okay, that establishes the baseline. Then stage 2 is the post-commit queue.
Right. Every single time you commit code, a Git hook fires in the background.
And hold on, as a developer, hearing a Git hook fires an AI model on every commit sounds like an absolute nightmare for my velocity. I mean, I cannot wait 30 seconds for an LLM to process every time I type git commit.
Oh, absolutely not. The architecture deliberately avoids that friction. The Git hook takes less than 5 milliseconds to run.
Oh, thank goodness.
Yeah, it absolutely does not call an AI model at commit time. It merely queues the commit SHA, the unique cryptographic ID of that specific code change.
So it quietly notes that a chunk of work happened, puts it in a queue, and lets you keep moving with zero disruption to your flow state.
Exactly. The heavy lifting is entirely deferred. Which brings us to stage 3, session end enrichment.
Right.
When you finish your coding session for the day, say you close your terminal or exit Claude Code, a stop hook fires. And that is when Rocky finally drains that queue of commit SHAs.
So it reads the Git diffs then?
It reads the diffs, but it goes a massive step further. It also reads the last several hours of your Claude Code session transcript.
Wait, really? The actual conversation transcript?
Yes. Integrating that transcript is what elevates the generated questions from just generic code analysis to hyper-targeted architectural probing.
I mean, think about what happens during a real 3-hour debugging session. You're wrestling with a complex database migration. You try 2 different approaches. The AI fails. You get weird constrained errors.
Yeah. And finally, on the 3rd attempt, you and the AI find a migration script that works, and you commit it.
Because Rocky reads that entire transcript, it captures your rough draft. It knows your intent. It knows the errors you hit and the alternative solutions you discarded along the way.
Right. So instead of asking, what does this migration script do? Rocky can ask, why did your initial approach to this database migration violate the foreign key constraint? And how does this final script resolve it?
That is so cool. It's interrogating your entire problem-solving journey, ensuring you internalized the struggle, not just the final copied and pasted solution.
It forces you to synthesize the messy reality of software engineering.
Okay, so practically speaking, what does this user experience feel like day to day? Because obviously we aren't answering these quizzes at midnight when we close our laptops.
No, usually it happens the next morning. You sit down with your coffee, you open your terminal, and you run Rocky Quiz.
Okay.
Rocky scans your personal knowledge graph, finds the topics that have decayed the most according to that FSRS algorithm, and presents you with a targeted question about the code you shipped yesterday.
You type in your answer, and Rocky evaluates it for genuine comprehension.
Exactly. And if your answer is close, but maybe misses a crucial nuance, it will actually ask a follow-up question to guide you there.
And what if I just completely blank?
If you admit you don't know, it steps back, explains the concept from scratch, and crucially, marks that node in the graph to be resurfaced much earlier next time.
That makes total sense. And all of this generates a quantitative metric called Rocky IQ.
Yes, the Rocky IQ.
It's a single score from 0 to 100, calculated on a 60-day sliding window. This means it heavily weights your most recent learning and forgetting.
Right. And there are specific thresholds. If your Rocky IQ is above 80, your mental muscles are intact. You have a firm grasp on the systems you're deploying.
But if it dips below 70, gaps are starting to open up.
And if you drop below 60, it is a glaring, objective warning sign that you are flying blind.
Yeah, you're relying entirely on the AI's logic, and you are basically one hallucinated bug away from a major production outage.
They also provide some fantastic visual tools to track this. If you run the Rocky View command, it spins up a local web interface.
I saw this in the notes. You get a literal force-directed graph of your brain's knowledge mapped onto your project, right?
Yeah. Nodes are colored by their retrievability score, and edges show how concepts relate to one another. You can physically see which domains of your application are fading from your memory the fastest.
That's amazing. And there's also a Rocky dedupe utility, because over time, as you interact with different AI models, they might log a concept as exponential backoff on Tuesday and retry with exponential backoff on Friday.
Right. Dedupe lets you clean up the graph by merging those near-duplicate nodes, which ensures your FSRS statistics remain completely accurate.
Okay, but I have to ask. Anytime we talk about a tool that parses source code, reads hours of developer transcripts, and analyzes architectural intent, we run into a massive, unavoidable red flag: privacy.
Of course.
If I am working at a Fortune 500 company or even an early-stage startup with proprietary algorithms, sending my raw Git diffs and AI chat logs to a centralized cloud server to generate quizzes, that is a firing offense.
It's a massive security violation. It's an absolute non-starter for any professional development environment.
Right.
But the Rocky team understands this fundamental constraint. That is why the entire architecture is local first by default.
Meaning none of my data ever leaves my physical machine.
Not a single byte. Your bit diffs, your Claude transcripts, the Squissout database containing your knowledge graph, your quiz answers, they never touch the network.
Unless you explicitly dive into the settings and configure an external cloud LLM provider.
Exactly. Rocky is engineered to work completely air-gapped using a local Llama model running directly on your hardware.
And they even built in a configuration flag for environments with strict compliance requirements. The privacy.strict flag.
Yes.
If you enable that flag in your config file, Rocky will proactively refuse to start if any cloud provider endpoint is detected. It literally creates a mathematical guarantee that proprietary data cannot leak.
Which is huge for enterprise adoption. And this local-first philosophy extends to their user interface updates as well, specifically the new voice mode introduced in version 0.2.
Oh, this is a huge friction reducer, because honestly, typing out a long, nuanced paragraph explaining a complex microservice architecture into a terminal window is just annoying.
Yeah, nobody wants to do that. With voice mode, you don't have to type. In the web UI, there's a push-to-talk button. You can just verbally explain the code exactly as you would if you were talking to a colleague during a morning stand-up.
Or you can trigger it from the command line with Rocky Quiz -- voice. The system reads the question aloud and records your spoken answer.
And true to their privacy mandate, that transcription happens entirely locally using the whisper.cpp model.
It perfectly mimics the natural verbal back and forth of a pair programming session.
It does. But zooming out from the individual developer experience, the sources highlight why this specific tool matters to the broader tech industry right now.
Yeah, so what does this all mean for the industry?
The skill atrophy problem has transcended the individual. It's rapidly becoming a systemic hiring and team reliability crisis.
The documentation actually cites engineering managers who are raising massive red flags right now. Managers are finding that developers who have relied heavily on Copilot and Claude for the last 2 years are becoming incredibly difficult to evaluate in technical interviews.
Right, because on paper, their output is phenomenal. They can stand at a whiteboard and architect complex, distributed systems beautifully.
Because the AI has been doing the detailed execution for them, so they are used to operating at that high architectural level.
But when an interviewer drills down and asks them to explain the specific low-level fundamentals underneath those systems, without a search engine, without an AI assistant, they freeze.
Their on-the-spot recall and foundational problem-solving skills have completely degraded, which creates a super dangerous market dynamic.
It really does.
Senior engineers who have actively maintained their foundational depth, the engineers who can actually spot the subtle logic-destroying bugs in AI-generated code, are becoming increasingly rare.
And because they are rare, they are becoming incredibly expensive to hire and retain.
The documentation actually makes a bold macroeconomic claim here. The engineering teams that will dominate the next 5 years of software development are not the ones who adopt AI the fastest. Speed of adoption is just table stakes now.
Yeah, everyone has access to the same tools. The true differentiator will be disciplined adoption. The teams that win will be the ones that pair the incredible velocity of AI generation with intentional, verifiable knowledge preservation.
They need their engineers to stay intellectually sharp, even as their output becomes increasingly leveraged by automation.
And Rocky is attempting to be the open source standard for that discipline layer.
Which brings us to the urgency behind this specific deep dive. Rocky is open source. It is a single cargo install command to get it running, and it's in heavy active development right now. The maintainers are putting out a massive call to action.
They desperately need alpha testers.
But they're looking for a very specific profile, right?
Yes. They need developers who are actively using tools like Claude Code or GitHub Copilot every single day in real-world environments.
People who are deeply comfortable in the command line, and more importantly, people who are willing to provide brutally honest, critical feedback.
Exactly. If you use AI to code and you are worried about your own mental muscles degrading, they need your input.
Yeah.
They are looking for signal on a few specific fronts.
Like real-world question quality, right?
Mm.
When Rocky reads your commits and generates a question, is it actually probing useful architectural knowledge? Or is it generating vague, easy, or disconnected trivia?
Right, because if the questions feel like a waste of time, the tool fails its primary mission entirely.
What else are they looking for?
They're also looking for feedback on the friction of the workflow. Do the Git hooks interfere with any of your existing CI pipelines? Does the timing of the session end pipeline interrupt your train of thought?
And furthermore, because the system relies on local Llama models to guarantee privacy, they really need data on which specific open source models do the best job at generating nuanced questions across different programming languages.
Yeah, that's crucial. And lastly, they want to observe the long-term growth patterns of the personal knowledge graph. If a developer uses Rocky consistently for 30 or 60 days, does the graph stay clean and actionable?
Or does the data degrade into noisy, overlapping concepts? They need to know how it handles extreme edge cases, like massive enterprise monorepos, code bases written entirely in non-English languages, or projects that completely lack a readme file.
So if you want to help solve the AI skill atrophy problem, you can find the project on GitHub. It takes 10 minutes to run through their tutorial smoke test, and they genuinely need your messy, real-world code bases to make this tool bulletproof.
It is a rare opportunity to help shape a piece of software that could eventually become as standard and necessary as a linter or a testing framework in a modern developer's environment.
It really is.
So, to bring this all together, we started by looking at a very real, very silent threat. The miraculous tools we use to write code faster are subtly eroding our biological ability to understand the complex systems we deploy.
The mental muscle deteriorates because the AI pulley system is doing all the heavy lifting. We're skipping the necessary cognitive struggle.
But tools like Rocky, powered by a local Svelte-like knowledge graph, spaced repetition algorithms, and deep context pipelines, all bring a disciplined way out.
By running silently in the background and forcing us to actively recall our architectural decisions, we can keep those neural pathways strong.
We can harvest the sheer speed of AI generation without sacrificing the hard-earned expertise that makes us engineers in the first place.
It is a proactive, verifiable approach to a cognitive decline most developers don't even realize they're suffering from yet.
It is. And before we close, I want to leave you with one final thought to mull over. We spent this whole time talking about how the personal knowledge graph prevents you from forgetting. But think about the inverse.
What do you mean?
Well, if Rocky succeeds, your personal knowledge graph becomes your portable intellectual property. It's a structured record of everything you genuinely understand that lives on your machine and travels with you across jobs. So if your technical skills are perfectly mapped in a portable graph, how long until submitting your personal knowledge graph completely replaces the traditional technical interview or resume? Keep your tools sharp and your minds sharper.